Have you ever stopped to think about your own breath? I mean, really think about it? It's something we do thousands of times a day without even noticing. Well, today we're going to change that. We are going on an incredible journey following a single breath from the air around us deep into the core of our bodies. So let me just start with a number. 300 million. Any guesses what that could be? It's not a population, it's not a distance. It's something you have inside of you, right this very second. Yep, that's it. You have roughly 300 million tiny, microscopic air sacs in your lungs. They're called alveoli, and let me tell you, they are the absolute heart of this whole operation. And just to give you an idea of how mind-boggling that is, if you could somehow take all of those tiny little sacs and lay them out flat, side by side, they would cover an entire tennis court. All of that surface area is packed inside your chest. It's incredible. And you know what the craziest part is? This entire super complex system runs completely on autopilot. You're breathing in, you're breathing out all day, every day, and you don't have to think about it once. Your body just knows. It's one of the most amazing automated systems in nature. All right, so let's actually follow a breath of air. Let's take a guided tour down what you could call the respiratory superhighway, starting from the very first moment it enters your body. Okay, so the journey kicks off the second you inhale. The air comes into your nose and goes down your pharynx, which is just your throat. But it's not just a simple pipe. This is like a prep station. The air is being warmed up, moisture is being added, and it's being filtered of dust and gunk to protect the delicate parts deeper inside. From there, the air swooshes past your larynx, that's your voice box, and then enters the main event, the trachea. You probably know it as the windpipe. This is the big main airway heading straight for the lungs. And this is where things start to branch out, literally. The trachea splits into two big tubes called bronchi. One goes to the left lung, one goes to the right. A great way to picture this whole thing is like an upside-down tree, and the trachea is the thick trunk. And of course, the branching doesn't stop there. Oh no, those two big bronchi keep splitting, again and again, into smaller and smaller pathways. These are called bronchioles, and they're like the little twigs of the tree, spreading out to make sure air gets to every single nook and cranny of your lungs. So after traveling down the trunk, through the branches, and along all the twigs, where does the air finally end up? Well, we've arrived at our destination. This is where the real magic happens, right down at the microscopic level. At the very, very end of those tiniest bronchioles, you find these little clusters of hollow sacs called alveoli. They look kind of like tiny bunches of grapes. And this is it. This is that tennis court-sized surface we were talking about. This is where the whole point of breathing takes place, the exchange of gas between the air and your blood. And these things are just perfectly engineered for this job. First, you've got that massive surface area. Then, get this, their walls are impossibly thin, just one single cell thick, so gases can slip right through. Each one is also wrapped up in a super dense web of tiny blood vessels called capillaries, and they're coated with a bit of moisture, which is key for helping oxygen dissolve so it can get into the blood. So here it is, the great exchange. In less than a second, oxygen from the air you just breathed in zips across that thin wall from the alveoli right into your bloodstream. And at the exact same time, the waste gas your body needs to get rid of, carbon dioxide, travels out of your blood and into the alveoli, ready to be pushed out when you exhale. It's a perfect swap. Okay, but hold on. How does the air actually get pulled in and pushed out? Your lungs don't have any muscles of their own, so they can't do it themselves. The secret, well, it's actually some really simple physics, powered by the muscles around your lungs.
It all comes down to a principle from science class called Boyle's Law. It sounds complicated, but it's not. All it says is that if you have a closed space, like your chest, and you make it bigger, increase the volume, the pressure inside drops. And if you make it smaller, the pressure goes up. That's it. That simple relationship powers every single breath you take.
So, to breathe in, two key things happen. First, that big dome-shaped muscle under your lungs, the diaphragm, it contracts and flattens out. At the same time, the muscles between your ribs pull your whole rib cage up and out. All of this makes your chest cavity bigger. And just like Boyle's Law says, more volume means less pressure. The pressure inside your lungs drops below the pressure outside, and air just rushes in to fill the space. Now, breathing out is even easier. It's basically effortless. All those muscles, the diaphragm and the rib muscles, they just relax. The chest cavity naturally gets smaller, the volume goes down, so the pressure inside goes up, and the air just gets gently pushed back out. Simple as that. So this elegant, automatic system works nonstop for us, day in and day out. But it's also incredibly delicate. Those tissues doing all that amazing gas exchange are so thin and so vulnerable, and they really need to be protected.
Just take a look at this. It's a pretty stark contrast. On one side, you've got healthy, wide-open airways and those nice, plump alveoli. But on the other side, you can see the damage from conditions like COPD. The airways are all narrowed, and those delicate air sacs are starting to break down.
So with something like chronic bronchitis, those airways, the branches of our tree, get all irritated and clogged up with mucus, which makes it really hard for air to get through. And with emphysema, the walls of the alveoli themselves actually break down. That shrinks our tennis court, right? It reduces the surface area, which makes it so much harder for the body to get the oxygen it desperately needs. So from a simple muscle movement to a lightning-fast gas exchange happening 300 million times over, every single breath is just a little masterpiece of biological engineering. You're going to take over 20,000 of them just today. Kind of makes you think, doesn't it? What an absolutely incredible journey each and every one of those breaths really is.